Now we are going to see the first come first serve scheduling algorithm in operating system, which is the simplest algorithm in the operating system, and it works exactly in a first in first out form, which means the process that makes the request CPU first, that particular process will be allocated by the CPU first. It means the process that arrives first in the queue, that will allocate by the CPU first. So let's see the example. This is the table. This is the table that describes the required time slots for each processes. Required time slot for each process. The process P1, P2, P3 and P4. The required time for P1 for execution is 5. The required time for P2, the execution time for P2 is 6. The execution time for P3 is 2. Execution time for P4 is 4. The time at which the process arrives in the queue, that is P1, has arrived in the queue is 1 at 1 milliseconds. P2 arrives at 0. P3 arrives 2 and P4 arrives 0 millisecond. Now, the waiting time for an execution, that means our process is waiting for an execution. The P1 waiting time for an execution is 9, P2 is 0, P3 is 13, P4 is 6. The finish time, that means the time at which each process finish its execution. The P1 finishes its execution at 15 milliseconds. P2 finishes its execution at 6 milliseconds. P3 finishes its execution at 17 milliseconds. And P4 finishes its execution at 10 milliseconds. Now, this algorithms requires the base of arrival time. It means which process arrives first in the queue. So, on the basis of this, I have drawn the Gantt chart. Now, this Gantt chart describes the start time of the process and the finish time of the process. That means the time at which the process starts its execution and the time at which process finish its execution. So this is a starting time and this is a finish time. So as we know, the arrival time of the P2 is first. In the series, the arrival time of P2 is first. That means 0. So in the Gantt chart, P2 will be written first. In the next, the P4 will arrive at the same time, that is 0. So in the series, the P2 has arrived. So hence, I have returned P2 first. And in the series, the P4 will be the next, though the arrival time of P2 and P4 is the same. So P4 will be returned next. And in the third position, the P1 will be returned. And in the fourth position, the P3 will be returned. Okay. Now, according to this, let's see how the start time and the finish time will be determined. Now the arrival time, as we know, the P2 is 0, but the burst time of P2 is 6. So what we are going to do is that we are going to add this 6 and 0, right? Because time taken by the P2 for the burst or for the execution is 6. So 0 plus 6 is 6. So at the sixth second, P2 has finishes its execution. It means the P2 has completed its execution. And at the same time, at the same sixth millisecond, the P4 has started. P4 has starts its execution. It means the time at which the first process has finishes its execution. At the same time, the next process has starts its execution. So the starting time of P4 is 6th. Okay. The start time of P4 is 6, but the burst time of P4 is what? Is how much? Is 4. So 6 plus 4 is 10. So at the 10th millisecond, the P4 has started. Sorry, the P1 has started. But the burst time of P1 is how much? Is 5. So 10 plus 5, that comes to 15. So 15th millisecond is a starting time for P3. But then what is a burst time of P3 is 2. So 15 plus 2, 17. Okay. So the finish time of P3 is 17 and the starting time of P3 is 15. So here we have got the start time and the finish time of each process. Fine. Now we are going to calculate average waiting time and the average turnaround time for each process. So let us see first how to calculate the average waiting time. But before we calculate the average, we are going to see what is the waiting time. What is the waiting time? So actually it is there in this table. It is there in the table, but we are going to cross check it. We are going to cross check it. Like whatever we have written here, is this the same or is there any different value? So now the formula to calculate the waiting time equal to start time minus arrival time. Start time minus arrival time. So first we'll see the start time. The start time of P1 is 10. Let's see whether it is correct or not. So the start time of P1 is 10 here. Okay, so this is 10. Fine. The start time of P2 is 0. Yes, correct. The start time of P3 is 15. Yes, it is correct. And the start time of P4 is 6. Let's see. Yes, it is correct. Right? So the start time of P4 is 6. Now, arrival time of each process. Start time minus arrival time, because the arrival time will be deducted from the start time. So let's see the arrival time of each process. The arrival time of P1 is 1, P2 is 0, P3 is 2 and P4 is 0. Now, see here the waiting time of P1. The waiting time of P1 is 9, P2 is 0, P3 is 13 and P4 is 6. Is it the same in the table? Yes, 9, 0, 13, 6. Okay. Now, what we are going to do here? Start time minus arrival time. So, the start time is 10 minus arrival time. So, 1. So, 10 minus 1, 9. Okay. 10 minus 1, 9. Now the next. P2. The start time is 0. Arrival time is also 0. So, waiting time for P2 is 0. P3. The start time of P3. The start time of P3 is 15. Arrival time is 2. So 15 minus 2, 13. So start time of P4 is 6. Arrival time is 0. So 6 minus 0, 6. Okay. Now we are going to add these waiting times of P1, P2, P3 and P4. So 9 plus 0 plus 13 plus 6. So that comes 28. The total comes 28. So 28 by 4 because the total number of processes are 4. So we got a value 7 milliseconds. So 7 millisecond is the average waiting time of these 4 processes. Now the last is we are going to calculate the average turnaround time. The average turnaround time. But before we are going to calculate the average turnaround time, let us see how to derive the turnaround time. The formula to derive the turnaround time is turnaround time equal to finish time minus arrival time. So we have determined the finish time by the Gantt chart. See, the Gantt chart given us the finish time. So the finish time for P1 is 15, P2 is 6, P3 is 17 and P4 is 10. Fine. Is it the same? Yes. We have got it. 15, 6, 17, 10. In this, just in the series order I have written here. P1, P2, P3, P4. And minus arrival time. Arrival time is there in the table. 1, 0, 2, 0. So 15 minus 1, 14. 6 minus 0, 6. 17 minus 2, 15. And 10 minus 0, 10. So we have got here the turnaround time for each process. Same as we have done the total for the waiting time, we are going to do the total for turnaround time. So we are going to add the turnaround time of each process. So 14 plus 6 plus 15 plus 10. The total come is 45. Whole divided by 4 because we are going to calculate the average. So total number of processes are 4. So 45 divided by 4, that comes 11.25 millisecond. So 11.25 millisecond is the average turnaround time for the 4 processes. Right? So I hope this particular scheduling algorithm FCFS must have understood to you.